Hello, my name is Hafiz Muradov and I'm going to show you how to solve tutorial 37 in Production Technology books in chapter 12. We need to find the operating point, which means that we need to find the rate at which well is flowing stable. For these conditions, we have a well equipped with 6,000 feet long tubing. We know tubing diameter, we know average reservoir pressure, we know our productivity index, it is also linear. We know that the wellhead pressure is fixed at the value of 160 psi, and we know our gas-liquid ratio. Because we only produce oil, you can as well call it gas-oil ratio at 400 standard cubic feet per barrel. Right. The well will be flowing stable if inflow pressure equals its outflow pressure at any node. This is the first principle of nodal analysis. And normally, when we design wells, we choose bottom hole as a node of analysis. So from now on, let's talk about bottom hole as our node. We need to find the rate at which our inflow bottom hole pressure equals our outflow bottom hole pressure. Now to show it to you graphically, if I draw a sketch of the well, if I have my casing here, my tubing goes all the way down from the surface, I have Christmas tree, I have my wellhead pressure fixed, I know my tubing length, I know my tubing diameter, I have my reservoir, and I know reservoir properties such as I know average reservoir pressure and I know productivity index. I also know my PVT property GOR here. Right. So if I choose bottom hole as a node of interest, then what I can say is this: my operating rate for this well will be such rate that my bottom hole pressure inflow is equal to my bottom hole pressure outflow. When I calculate my inflow pressure, I start from the reservoir up. When I calculate my outflow pressure, I start from the surface down. So I need two equations describing my inflow and outflow curves, and then I need to find the rate at which this equality will be correct. Let's calculate our bottom hole pressure inflow first. So we start with our reservoir pressure. My pressure here will be reservoir pressure minus pressure losses across the formation. We call this pressure losses, or across the reservoir, we call it drawdown, and by definition, by definition of productivity index, it is equal to rate divided by drawdown. So I can write down here that my bottom hole inflow will be equal to my reservoir pressure minus rate divided by productivity index. This equation here describes inflow bottom hole pressure. Now if I want to describe my outflow bottom hole pressure, then I start from surface. I know that my wellhead pressure is fixed, and then I add pressure losses which happen across the whole tubing length. So pressure losses across tubing. If I solve this equation now here, I will be able to find my operating rate or operating point. We prefer to solve it graphically instead of doing this mathematically, which means that we prefer to plot our inflow performance relationship and outflow performance relationship at the same graph. By default we have well rate here starting from 0, right, and bottom hole pressure and the vertical axis started from 0 up. So this intersection point here will automatically mean the solution of this equality, and it will give us the well operating rate and operating bottom hole pressure. So in order to start doing this, we need to plot our IPR and OPR curves first. Let's start with IPR. We know that the PI is linear, so IPR will be just a line here. To draw a line, you only need 2 points. I normally prefer to choose the first and the last point here. If the well is not producing anything, if the production rate is 0, then apparently our bottom hole pressure will be equal to the reservoir pressure. So this point here, it's simply reservoir pressure. Now, however, if our bottom hole pressure is 0, then the well will be flowing at the maximal rate. This rate is called absolute open flow rate. And from this equation, you can simply see that the absolute open flow rate is equal to Pi multiplied by the reservoir pressure. The maximal drawdown we can achieve across the formation is the reservoir pressure. So my rate here is equal to Pi multiplied by reservoir pressure. Okay, I have these 2 points. I connect them with a line, and now I have my inflow performance relationship. Let's do this for this particular problem in Excel. Let me delete this. Right, if I'm about to find the curve for inflow performance relationship, and I will be plotting my rate at the horizontal axis versus my BHP as the vertical axis. If I'm not producing anything, my BHP, as I said, will be equal to my reservoir pressure, which is 2700 psi. If I bring my BHP down to 0, I will be producing maximum rate possible, and this is equal to my Pi multiplied by reservoir pressure. So it will be my Pi multiplied by the reservoir pressure. Okay, so I have these 2 points, enough to draw a line, and now I plot it. This will be my inflow performance relationship. Now let me title the axis. This is my rate in barrels per day, and vertical axis is my BHP in PSIs. This curve is called inflow performance relationship, or IPR. Right. Now if I go back to my drawings here, we now have to find our outflow performance relationship, this curve here. However, to calculate it, we need to calculate pressure drop across the tubing, and unfortunately we don't have an equation describing it. So what we will be using is charts. If you go to your book and open the charts at the end of the chapter 12, so we need to find the pressure traverse charts for a 4-inch tubing case and oil production. If I go down, this is 2 inches diameter, 2 inch. So I go down Yes, excellent. I have charts for all oil 4-inch tubing cases here for different rates. I have the chart describing pressure losses if I am producing at 1000 barrels of oil per day. This chart describes pressure losses if I am producing at the rate of 2000 barrels of oil per day, and so forth. So if I find my different BHP at different rates, 1000, 2000, 3000, 4000, then I will be able to draw this curve here, and then I will be able to find the intersection point. Let's find our bottom hole pressure if I'm producing at 1000 barrels of oil per day first. Okay, so essentially we will be using this chart describing pressure losses for 1000 barrels of oil per day. It's this chart here. I know that my wellhead pressure will always be 160 psi. Sorry. Yep. And I know that my tubing length is 6000 feet. So I need to find bottom hole pressure at which, if the well is producing 1000 barrels of oil per day, I will have wellhead pressure of 160 psi. If I'm using this chart and I know that my wellhead pressure should be 160 psi, which is approximately value here, I draw a line across 160 psi and I find the intersection of this line with the pressure curve for 400 GOR, and the depths of this intersection point will be my equivalent depths in this case. Now, if I measure from this depth down 6000 feet my tubing length, it will give me approximately 8700 feet. So this depth here. Intersection of this depth with this 400 GOR curve will give me the bottom hole pressure which I need to have if I want to produce 1000 barrels of oil per day, and if I want to keep my wellhead pressure at 160 psi. So once again, let's start from the other side. If I have my bottom hole pressure at about 960 psi here, then across 6000 feet I will have pressure losses such that at the top of the 6000 feet, in my case at the wellhead, I will have the pressure value of 160 psi, which is exactly what I need. Right? Okay, so this means that if I want to produce 1000 barrels of oil per day, I need to have my bottom hole pressure at 960 psi. And in the same fashion, I analyze other charts, the following charts here, and I find the values. I will simply take them from the solution. I will simply take them from the solution. So I guessed right. For if I want to produce 1000 barrels of oil per day, I need to keep my bottom hole pressure at the value of 960 psi. If I want to produce 2000 barrels of oil per day, and if you calculate it from the chart, you will see that you need to keep the bottom hole pressure at the value of 1000 psi. For 3000 barrels of oil per day, we need BHP 1085, and for 4000 barrels of oil per day, we need to keep bottom hole pressure at the value of 1160 psi. Now let's add this curve to this graph here. So if I add another curve with these rates and these BHPs, and we call it outlet performance relationship. We also call it vertical lift performance, VLP. Then the intersection point is our operating point, and the rate here, which is around somewhat like, well, graphically you can only estimate it approximately. It will be somewhat like 2200 barrels. So my operating rate will be about 2200 barrels, and my operating bottom hole pressure will be around 1000 psi. You will have to calculate these values more accurately when you will be using your line sheets. Let's compare my value against the correct value in the tutorial solution. Yes, so the rate is interesting. Right, okay, I see the problem. I think I've swapped this line here. My X is actually my rates, and my pressure is pressure. Right, that should be, yes, this looks more like it. So my rate is about 3600 barrels of oil per day, and my pressure is about somewhat like 1100 psi. And if you compare it against the solution given in the book, you will see that we are quite close to the accurate solution. So this is how you solve this kind of problems. If you want to find the operating point, you have to plot inflow performance and outflow performance relationship at the same graph and find the intersection point. Normally we are able to use equations when we are plotting inflow performance relationship, like in this case we used linear PI equation. However, if we are plotting our outflow performance relationship, we normally have to use charts. And as I said, in order to use chart, you have to start with your wellhead pressure. You have to find your equivalent depth for this, for your particular GOR curve. You have to measure down your tubing length, and the intersection and the value of your GOR curve at this particular depth will give you bottom hole pressure. Finding these bottom hole pressures for different rates using different charts, you will be able to plot your outflow performance relationship, and the intersection point will give you the solution. Thank you.